press the bell icon on the YouTube app and never miss another update.
Okay, students, in the previous session when we have discussed about non-uniform accelerated bodies, some calculus based problems we have studied. In that calculus based problems, use of differentiation very well we have discussed, and use of integration, like only one small problem I have given at the end. So let me mention a few more problems related to the based on integration, right, how we have to solve for quiet parameters, how we have to solve with them, just study. Yesterday we have taken variation of velocity with time, Now I am going to say variation of acceleration with time, like acceleration, how it varies with time means some t square plus t, so many meter per second square I am going to say. Acceleration is varying with respect to time according to the relation t square plus t, so many meter per second square. Now they are asking to find out what might be the change in velocity. What is change in velocity during an interval of time, some 2 seconds to 4 seconds, what will be the change in velocity they will ask. How to solve for it, right? How to solve for it, we will see now. Find change in velocity during an interval of time from where to where t1 equals to 2 seconds to t2 equals to some 4 seconds of time, or t equals to 2 seconds to t equals to 4 seconds of time. During this time interval, what will be the change in velocity of the body they are asking. How to find out? I have told you clearly the use or importance of integration in physics. In the previous session when I have taken an example, I have plotted a graph between velocity and time and how velocity varying with respect to time we have seen. Small area under Vt graph gives what displacement we have studied and we have plotted. Here variation of acceleration with time they have given. So from that, you know acceleration means what? A equals to dv by dt. Acceleration is dv by dt. From this, dv is nothing but change in velocity only, right, or variation of velocity with respect to time. dv it will be equals to a into dt. dv equals to a dt. I want the change in velocity during an interval from where to where? From where to where? T equals to 2 seconds to t equals to 4 seconds. How the velocity changes during that interval? Let's say at t equals to 2 seconds velocity is v1 and t equals to 4 seconds velocity is v2 I am going to say. Then integral of dv equals to what? Integral of a into dt, where the values will change from where to where? 2 to 4 seconds. 2 to 4 seconds. During this time from 2 to 4, velocity changes from where to where? v1 to v2. We don't know what is the value. This is v1 to v2. Therefore, integral of dv is what? V. Limits from where to where? v1 to v2 equals to integral of a is nothing but what? A is nothing but t square plus t they have given. T square plus t. Let me take that. T square plus t into dt. Limits from where to where? Like 2 to 4 seconds. Let's again go for the integration for the right hand side. On the left hand side, what you are having? V from v2 to v1. v1 to v2. Applying the limits for this, what you get? v2. In place of v, I have to substitute v2. In place of v, I have to substitute v1. So you will get v2 minus v1, right? v2 minus v1 will be equals to, do the integration of t square plus t into dt. How much you will get? This is t cubed by 3, limits from where to where? 2 to 4, plus integral of t dt is what? T square by 2. Also for this, limits from where to where? 2 to 4. You have to apply the limits likewise. Do the integration individually, apply the limits individually for that each function. Similarly here also the same thing. Now 1 by 3 is common, or v2 minus v1, that is what the velocity difference they are asking to find out. Change in velocity means v2 minus v1 only, na? At t equals to 2 seconds velocity is v1, at t equals to 4 seconds velocity is v2. Change in velocity means what? v2 minus v1 only, right? That's what they are asking to find out. v2 minus v1 equals to, this is 1 by 3, I will take out, remaining is what? T cubed from 2 to 4. Means how to apply the limits? First upper limit is 4 cubed minus lower limit is what? 2 cubed. That's how we need to apply. Plus, here once again 1 by 2 is common. If I take it out, remaining is t square from 4 to 2 means 4 square minus 2 square. This is the way how you need to apply for the limits. Just find out the value. Change in velocity v2 minus v1 equals to, this is 1 by 3 into 4 cubed is what? 4 4 64, 64, sorry 4 4 16, 4 is 64 minus 2 cubed is what? 8 plus of 1 by 2 into 4 square is 16 minus 2 square is what? 4. This is 16 minus 4. Rewriting this, v2 minus v1 equals to 64 minus 8, 56 divided by 3 plus this is 16 minus 4, 16 minus 4 is 12, 12 by 2 6 like this, or simplify this, how much you will get? 3 6 18, 56 plus 18 means 66, 40, 46 66, sorry 56 plus 18 means 44 you will get 40, 44 3 6 18, 56 plus 18, 56 plus 18 means 66, 74 you will get, 74 divided by 3, approximately whatever the value you will get there, you have to keep it, simplify that. This is how you need to find out the change in velocity, how you need to find it out. This is a method. In this, if they have already known that at t equals to 2 seconds, see at t equals to 2 seconds, if velocity is 2 meter per second they are given. How much is the velocity at v1 they are given? That is at t equals to 2 seconds, if speed is 2 meter per second, then find the speed at 4 seconds. At t equals to 2 seconds, the speed is 2 meter per second already. Then find the speed at 4 seconds in the sense, substitute for v1. v1 is how much they are given already? 2 meter per second. Substituting that, adding you will get one more value v2. If they are asking, I am telling you. If it is not, just if they are asking to find out change in velocity, directly you can find. At that instant, what is the velocity? Means you need to know what is v1 earlier. Then only you can find the value at v2. And v2 value only they are supposed to ask. So you are supposed to substitute for v1 value here. If they ask initial velocity is 0, at t equals to 2 seconds, if velocity is 0, if I say, then v1 will be 0. Then directly you can solve for v2. I hope you got this point. Problem related to velocity, how you need to find. If they are given acceleration, variation of acceleration with the time if they are given, how to find out the velocity with respect to time, and velocity how you need to solve for it by applying the limits over there. This is the one method you have to remember. And in the previous class, right, I have already mentioned about variation of displacement with time, how it is, how we need to find for velocity also we have studied in that part. Next, so like this the calculus based problems are going to be there. I'll explain remaining problems or remaining calculus related numericals by the time when I am going to discuss about the assignments. Once again I am going to discuss them. So I hope you got the idea in related to what differentiation and integration, how we need to solve for in case of non-uniform accelerated bodies. Uniform acceleration means straight away we have studied for kinematic equations and how to solve the problems we have studied there. So now thing is, till now we are all studying about horizontal motion. If a body moves only in horizontal direction, right, all the equations what we have studied or all the problems what we have done or everything are only for what? Horizontal motion in a straight line. Means the body is moving only in x direction, okay, that is in horizontal direction. How the motion it is? Corresponding to that only we have solved or we have described everything. Next type of motion we are having is vertical motion. If I am going to throw a body vertically up, it just comes down like that only in the same path. Once again it is nothing but what? Straight line path only. It just moves up and once again comes back in the same path. Straight line path only. One in forward direction, the other one is backward direction. how it is going to move, what is the nature of that motion. Of course, it is a straight line motion. How nature means whether it moves with uniform velocity, uniform acceleration, or non-uniform velocity or non-uniform acceleration, what nature it is, what exactly making it to move up. By the time you are throwing it, that's why it is going to move up. If it is continues to move up like that only, that ball or that body will never return back again. But still, its velocity goes on, decreases and finally becomes zero at maximum height, and once again makes a transition back in the opposite direction. What makes it to fall in opposite direction? What is the exact reason for that? So that is the concept of gravity. Motion under gravity. For a straight line we have to study. For a body moving in a straight line path, right, under gravity, motion under gravity, so that we have to study under the next heading. So before going for that, I just want to confine with few graphs again, only for the make use of to derive an equation. Kinematic equations, I have explained two graphs over there, namely I remembered, like velocity time graph, uniform acceleration how it is, displacement time graph, uniform acceleration how it is, uniform velocity how it is. I have plotted only two graphs over there. So now in depth about all the graphs, which type of curves you are going to get, which type of graph, not only straight line, uniform velocity or uniform acceleration for displacement time graph how it should be, retardation means how it is. We have run only for accelerated, uniform acceleration, increasing in the speed or increasing in velocity only we have run. How if velocity is negative or how acceleration is negative. Acceleration negative means what? Retardation. If I am going to apply the brakes, how the nature of the graph it is, how we need to find out. And also, which parameter can be found from which graph? Like what we can find from displacement time graph, slope of displacement time graph gives velocity we have studied. Slope of velocity time graph gives acceleration we have studied, isn't it? Area under velocity time graph gives displacement we have studied. Area under acceleration time graph gives velocity, average velocity we have studied. So likewise, all the complete details regarding the graphs we are going to study here. Now make the heading as graphs. Graphs, very important, remember, graphs we are going to study. Firstly, position time graphs. For all kind of xt graphs, wish to say xt graph are position hyphen time. Position time graphs we are going to find out first, or we are going to draw first. In all the cases, first one, body at rest. For a body at rest, how the position time graph is going to be. For a body at rest, how the position time graph. I am going to take in all the cases time axis as the x-axis, position as y-axis. That's what. In all position time graphs, we are going to draw for it. First one is what? Body at rest. Body at rest means I can say this body at rest, it is at 0 meter mark, or I can also say that this one also, this is at some x naught. I am going to say initially the position of the particle is some value, whatever it may be, 2 meters or 10 meters or whatever it is, some x naught I have written. Any axis which is parallel to, if the ray is, or if whatever the line if I am going to draw is parallel to the time axis, then in case of position time graph, okay, if the graph is parallel to time axis, wherever it is parallel, then you will say that body is at rest. There is a representation. Not only it should be at 0 meter mark, it can be at 3 meter mark also, means from the starting point, I am going to keep a particle somewhere at 3 meter mark, I am going to leave it there itself. It doesn't move at all from one place to other place. Then we will say that it is at rest. Okay. So next, body moving with uniform velocity. For uniform velocity. Now see here, uniform velocity. This is starting from origin. I will write here. See, this is position and this is time. Here the particle is starting from where? Origin. At t equals to 0, x equals to 0. This is what? Uniform velocity. Slope gives what? Slope of this graph. This is delta x and this is delta y. Slope equals to what? Delta x, and this is delta t, you can write otherwise. Delta x by delta t gives average velocity. Displaced slope of displacement time graph gives what? Average velocity. That's what. Not only that, one uniform velocity, this is 2, in that a I have taken 2a. 2b I will take, what is that? For a body moving with uniform velocity only, but at t equals to 0, x is not equals to 0, it is at x naught. Let me say it is going to start. It is starting from where? X naught. Then the position time graph supposed to be like this. This one. Slope positive means, and it is a straight line. For example, uniform velocity means it should be a straight line like this. Position time graph will be a straight line, no doubt. At t equals to 0, where the particle is at x naught. It is not starting from origin, or it is not starting from 0. X naught, initial position is there for the particle, but moving with what? Uniform velocity. Here slope remains constant, delta x by delta t. So that is delta x by delta t, it remains constant. This is called uniform velocity. Okay. Uniform velocity but with a negative sign. What do you mean by that? Traveling in opposite direction. Traveling in opposite direction. See, this is C I will mention. These are all the points for what? Uniform velocity. Negative velocity. Negative uniform velocity only, but it is negative. Means, what is the meaning of that? It is traveling in opposite direction. It is traveling in opposite direction like this. Initially at t equals to 0, the particle is at x naught. As the time passes on, right, it is moving towards the origin, right, or its displacement is decreasing with the time. How it is decreasing? Uniformly. So that's why it is uniform velocity only, no doubt, but it is negative uniform velocity. Uniform velocity but in the opposite direction, you can say. Okay. So this is displacement time graph for a body moving with uniform velocity. These three different conditions you have to write. Negative sign. Here slope will be negative, no? Here delta x by delta t is constant, no doubt, but negative it is. Constant but negative. So that's why it is uniform velocity, but the velocity will be negative in this condition. So this is one point related to displacement time graph, what you have to remember, these 3 points. This is all for what? Uniform velocity we have studied. If the body is moving with uniform acceleration, how the graph it is supposed to be? So that we'll write. Uniform acceleration. This is xt graph only we are going to study. Now we are drawing about uniform acceleration. Uniform acceleration, these are important, bit complicated. Xt. This what? Positive slope you are going to have for this. Means increase in velocity is going to be positive. Equation for this motion is like, this is for uniform acceleration, remember. Uniform acceleration, that too, acceleration is positive here. Acceleration is positive acceleration. X equals to some x naught plus ut plus half at square. This is the graph, this is the equation corresponding to this motion. Here a is positive, remember. This is the graph which represents parabolic equation. How the value of x is varying with respect to time? T square we are having, t term we are having. This is something like an equation which represents a parabola of this kind, right? Of this kind, and the a value will be positive in this condition. If it is uniform acceleration with negative value, if I am going to mention, how the graph is supposed to be? Negative acceleration, displacement time graph of this kind it is. Okay. So this is for no doubt body moving with, this is displacement time graph for uniform acceleration, and the value of a is negative here. Acceleration is negative. Negative graphs for position time graph for representation is like this. This is of this kind, x equals to some x naught plus ut minus half at square. The value of a is what here? Plus of minus a is going to be negative in this equation. This is of this kind, like y equals to ax minus bx square form it is. If I take x on x-axis, y on y-axis, that value we are going to have it as what? Negative, minus b. Similar to that kind, a is going to be negative. And this nature of this geometry of the curves you are going to learn in conic section in mathematics again. Conic section. What do you mean by ellipse? What do you mean by triangle? Right? What do you mean by a circle, semicircle, a cone? Right? All this nature of those curves. Not only this, a straight line means what it is. Y equals to some mx plus c if I write. What does it represent? A straight line, right? And once again, x square plus y square equals to r square or something. This is a circle. And x square by a square plus y square by b square equals to some c square or 1 or something if I am going to write. What does this represent? An ellipse. So like this, and y square equals to some 4ax if I am going to write. This is a parabola. In conic section, in mathematics, you are going to come across all the nature of the curves, what they are going to be. What is a curve and its equation? Circle means x square plus y square equals to r square. This is a circle with center at origin. Similarly, center at other point means x minus a whole square plus y minus b whole square equals to some r square, radius square you are going to get. There, what is the center of that? How to find? So, like this, you are going to learn nature of or geometry of a curve, whatever the type of curve if they are going to give, right? How that nature it is going to be based on the equation you can decide. Okay. So, based on the equation you can decide what is the nature of that curve, whether it is a parabola, whether it is a hyperbola, you are going to have one more equation, hyperbola, right? Or it should be ellipse means how it should be, right? So, like that. So, based on these are all like certain equations which you can represent for different shape of the geometry of the figure, whatever it is. Okay, in mathematics in conic section you are going to learn that, but as of now if you remember this, what does this represent? This is a curve which represents what? Body moving with uniform acceleration, no doubt with positive acceleration of this kind, the equation for this curve, and here uniform acceleration no doubt but with negative acceleration of this kind of equation you are going to have this of this form, ax minus bx square form. This is the graph we are going to draw. Not only these two, even, see, if I am going to write like a graph supposed to be like this, right? This is position, how it is decreasing with respect to time, they have given like this the graph. This is a part of this one only, right? See, this is once again uniform acceleration, remember this. This is uniform acceleration, and that too, acceleration is positive or negative, they'll ask. Definitely they are going to, you have to say mention that A is positive in this condition. And another graph, see, I have drawn here like this I am going to mention. Is this displacement time graph, whether acceleration is negative or positive, they will ask here in this condition. See, this graph is a part of this, isn't it? If you are going to find, right, A value are going to get negative in this condition. A value is going to be negative for this condition. So, like this, you have to remember for displacement time graph. See, I have given for displacement time graph at rest, displacement time graph for uniform velocity with positive slope and negative slope. How the slopes they are going to be, we have written acceleration and that too uniform acceleration in two cases, positive acceleration and negative acceleration. Positive acceleration is change in velocity is equal in equal intervals of time. Change in velocity is equal, not velocity is equal here. Change delta V is same in equal intervals of time. That too delta V value is positive. Its speed goes on increases. It is increasing at the rate of 2 meter per second in 1 second. In next second it will become 4 meter per second, next second 6 and so on. Means its velocity is increasing, no doubt, and change in velocity is equal in equal intervals of time. That is uniform acceleration. And if it is positive, speed is increasing means it is positive. Speed is decreasing means it is going to be negative. Here, no doubt change in velocity is equal in equal intervals of time, but speed is decreasing. Uniformly you are going to apply, brakes have been applied so that the vehicle is retarding uniformly. Meaning is, its speed is reducing equal in equal intervals of time. Reduction of speed is equal in equal intervals of time. That's why it is said to be what? Uniform acceleration but with the negative sign. Uniform retardation you can say. Okay. I hope you got all the points related to displacement time graph, how you need to plot for it. This is how we need to plot the position time graph or displacement time graph are different types of motion. Hope you have written all the points over there. And next one, velocity time graphs we'll study. Velocity time graphs. Velocity time graphs. This is VT graphs, which to say VT graphs. Firstly, body at rest. If I say body at rest means no doubt a line which is along the time axis. What does it represent? Body at rest. This is 0. This is for body at rest. Body at rest means what? V equals to 0, na? V equals to 0. This is the graph. This is variation of velocity with respect to what? Time. Okay. For a body at rest, V equals to 0. It is at rest, it's not moving. That's why its velocity will be 0. Now, body is moving with uniform velocity. What is that? Second one. For uniform velocity. Uniform velocity. What is for a body moving with uniform velocity? How to plot the graph? Like this. This is for uniform velocity. Where uniform velocity, sorry, this is not uniform velocity. Uniform velocity. This one. Some V naught, it is constantly moving with this uniform speed here or uniform velocity in the same direction, in one direction itself. Well, uniform velocity, this is. Next, uniform velocity but in the opposite direction. If I say this is A, I will say uniform velocity and the velocity value is what? Positive. If I say uniform velocity but negative velocity, if I am going to mention B in the 2, B uniform velocity but negative. Uniform velocity only. Body is moving with what? Uniform velocity but velocity is negative. If I want to mention how the graph it is. If this is time graph, if I take V on this y-axis, somewhere at this point, like this, parallel to time axis, minus V naught is the velocity. Throughout the velocity is going to be, no doubt, it is going to be constant, and but throughout the motion, negative velocity means what? It is moving in the opposite direction, you can say. It is moving in negative x-axis. If I say, obviously its velocity will be negative, you can mention. That's what. Moving in direction just mentions here, these two. They have the difference between these two graphs here. How we need to plot for it. Next one, uniform acceleration. Uniform acceleration. Uniform acceleration. So what is this uniform acceleration? For a body moving with uniform acceleration, how we need to plot the graph? This velocity and time, this is the equation. Any point if I take, velocity is going to be constant. What is the nature of this graph? If I say at t equals to 0, the value of v equals to 0. V0 means A is constant here, no? This is delta V, this is delta T. Remember, slope gives what? Velocity, average velocity. Delta V by delta T is what? Constant here. Constant. And that too it is positive or negative. Slope is positive here. That's why A is positive. Uniform acceleration, also acceleration is positive. What is the equation corresponding to this motion if I want to write? How to write the equation? Like V equals to, initial velocity is 0 plus AT. Or directly I can write V equals to AT. Remember this. V equals to what? AT is the equation you can write for velocity time graph at any point if you want to mention, right? Or else it is not required. Slope gives what? Velocity. Okay, slope gives what? Acceleration. Okay, so what does area under this graph gives? Area under this graph, delta V into delta T, what does it gives? Velocity is displacement by time. Velocity into time is nothing but what? Displacement. So I can also find here, area gives displacement. Remember this, area under VT graph gives, area gives displacement. displacement. How to find area means x equals to, this is like delta v into delta t, integral of delta v into delta t or anything, or area you can find out, displacement you just remember. How I can find out means, if it is t1 and t2 minus t1, based on the nature of the curve you have to find, I can't write directly here delta v into delta t, area half into base into height if it is a triangle. Rectangle means length into breadth, square, side square you can say, like that you can find out the area if you know the parameters over there. This is one thing about what? Uniform acceleration. Uniform acceleration only, one more, this is third one, I will say it as A. What is that? A. What do you mean by that? Positive acceleration. Now I will write uniform acceleration but negative acceleration. Negative acceleration, and that too it should be what? Uniform. How it is possible? Means plotting the graph like this. No doubt this is velocity, right, and this is time. What does this represent now? It started from somewhere at this point and its velocity goes on decreasing with time. How it is decreasing? Uniformly, no doubt. Here slope is negative. Slope is negative. Remember this point. Implies acceleration is negative in this condition. Uniform acceleration but negative acceleration you can say. That's what the graph represents. Okay. So that's the graph which represents what? Negative acceleration, or you can also call it as what? Deceleration or retardation. Deceleration or retardation. So that is one point you have to remember regarding uniform acceleration. VT graphs, all these are. Non-uniform velocity, it just moves in different way. This is what non-uniform velocity one. But uniform acceleration, acceleration constant, velocity is with. Non-uniform acceleration, what is that? Non-uniform acceleration for displacement in terms of what? Velocity time. Non-uniform acceleration means what? It's not a straight line. It's not a straight line. Just like the equations which we have written earlier, no? For displacement time graph, uniform velocity means we have written, right? Acceleration time graph means how the curve you are going to write. Non-uniform acceleration means it's not a straight line. It is going to be some other form. Just a graph you can draw like this. See, at this point velocity is one value. At this point velocity is some other value. Okay. So then you can say this is moving with non-uniform acceleration. Okay. So this is all about the velocity time graphs what you have to remember with. And now let me plot the graph for AT, acceleration and time. Graph between acceleration and time. AT graphs, acceleration and time. If I plot the acceleration on one direction y axis, at the same time on other direction, uniform acceleration means what? This is a graph like this. At all the points, A equals to constant. A equals to constant. This is what the graph. And if I find the area under this graph, what does it gives? Area under acceleration time graph gives average velocity. Area gives what? Average velocity. Average velocity for what? Area under acceleration time graph. Non-uniform acceleration means the value of acceleration goes on, changes. Accordingly, a number of graphs in different ways you can plot the graphs. This is very important. A0, acceleration is 0. What do you mean by that? Acceleration is 0. If I plot the graph like this, so like this, here the value of A is 0 if I am going to mention. What does this represents? Can you tell me? If AT graph they are given like this, A equals to 0, what does this represent? When A is 0, when V is constant, means what? Uniform velocity. Uniform velocity. For a body moving with uniform velocity, acceleration is 0. This is the nature how you have to represent time axis. For AT graph, if the graph is along the time axis, then the body is moving with uniform velocity. Wherever in the problems, in certain kinds of problems when you are solving, if you are going to get the problems, negative acceleration means, what is the meaning of negative acceleration? So if I plot the graph like this, E, right, and this is time axis. If I represent the graph like this, what does this mean? Acceleration is uniform, but it is negative, some minus a naught I will mention. It is constant throughout. Okay, so this is negative acceleration. Negative acceleration, the graph, how it is going to be. Okay, and after that, if I am going to plot something like this, what does this mean? A and T. A and T. Acceleration is increasing. Yes or no? With respect to time. How it is increasing? Is it uniform acceleration? No. Increase in acceleration is uniform. Here acceleration is not constant. Remember, this is A is not equals to constant here. A is not constant. Change in acceleration is constant. Means what? No doubt acceleration is increasing. Don't be confused with this is uniform acceleration. This is not uniform acceleration for AT graph. This one is a uniform acceleration for AT graph. Means change in velocity is equal in equal intervals of time. But whereas here change in acceleration is equal in equal intervals of time. Understood? That doesn't lead to any other parameter. Remember, just you can say that acceleration is increasing. How it is increasing? Uniformly it is increasing. Meaning is, in 1 second, if acceleration will be 2 meter per second square, after 2 seconds it should be 4 meter per second square. Means 4 minus 2. Increase in the acceleration is uniform in equal intervals of time. That's what? Increase in acceleration is uniform. Remember this point. What is this one? Change in acceleration is uniform, not acceleration here. How to take change in acceleration, to confuse they will ask this. Change in acceleration is uniform. Keep this point in mind. Here acceleration is not constant. Acceleration is varying. Change in acceleration is uniform. Why the slope is constant here? What does the slope gives? Slope we are not bothered here. Just slope doesn't give any term here. Slope means acceleration by time. Acceleration by time we have not defined anything. There is no any other term to define acceleration by time there. Acceleration by time means how acceleration is varying with respect to time. Means how the change in acceleration is equal in equal intervals of time. That's the meaning of this. Change in acceleration is uniform, but not acceleration. Keep this point in mind whenever they are going to give the graph of this kind. And the change in acceleration is also positive. Acceleration is increasing. You are giving the acceleration, no doubt. And that acceleration is also how it is increasing. That to positive value. How it is increasing? Equal in equal intervals of time. Change in acceleration is equal in equal intervals of time. So don't have any confusion with this uniform acceleration and change in acceleration. Particularly be clear with that particular point. So this is all about the different types of graphs what we are having and how we need to make use of representation of the graphs for different types of or different kinds of problems while we are solving. I'll solve the kind of problems over there. Probably vertical motion, right? We'll see if time persists. We'll start in this session itself, or else let me discuss that in the next session. That what is that? Vertical motion. Let me discuss that in the next session. So let me check the time. Okay. So some graphical problems we are going to solve now. Graphical problems. How can you find the slope if they are given an angle theta with the x-axis? Slope tan theta is slope, you are aware, right? Opposite by adjacent. I think you are aware of it. So now numericals will solve on the graphs there. Just take displacement and time. Two bodies have been represented like this. This is body A and this is body B. This is of 30 degree and this is of 60 degree they have given, for example. These are all very basics. This of 30 degree and this of what? 60 degree. This is the nature of the graphs, or the body A is moving in this particular way and body B is moving in this way. No doubt both are moving with uniform velocity. A is, why? Because this, what does this graph represents in case of xt graph we have studied? Body moving with uniform velocity. So A is moving with uniform velocity and B is moving with uniform velocity, no doubt. But are the velocities of A and B are equal or not? How you can say? You know, slope gives what? Velocity. Here in VT graph, slope gives velocity, no doubt. Slope gives velocity. Here for A, right, velocity of A is nothing but what? Slope. Slope of this graph you have to find. How to find the slope? Not only delta x by delta t, tan theta is nothing but opposite by adjacent only, na? Opposite by adjacent is nothing but what? Tan. So they have not given any length and this length of this and length of this they are given. If we can find out even like delta x by delta t, you can solve and you can do it. But directly you can make use this tan 30. Slope is how much? Tan 30. What is the value of tan 30? Tan 30 value is how much? Sin 30 is 1 by 2. Cos 30 is what? Root 3 by 2. So tan 30 value is 1 by root 3. This is the slope. Means velocity of A equals to 1 by root 3. Similarly for B, velocity of B equals to what? What is the value of velocity of B? Velocity of B equals to, is it blurred? Okay. So velocity of B equals to what? Slope. Once again it will be equals to what? Tan 60. What is the value of tan 60? Root 3. So therefore, which is bigger or which is smaller, anything they may ask the question like that. That's why velocity of A is less than, okay. Velocity of A is less than velocity of B. Any problem they may ask, or what is the value of VA by VB? In the options they will give. In 4 options what they will give in the numerical, they will ask, if this is the case, displacement time graph is as shown, then what is the ratio of velocity of A to velocity of B? What is the value of velocity of A to B? 1 by root 3 divided by root 3 means how much it is? 1 by, this is root 3 whole square, it will become 3. This is the value. Or VB, it will be equals to what? 3 times the velocity of A. That's the relation among these. That's how you need to write for it. This is one typical problem you can remember for what? Position time graph, how they are given, how you have to remember for what? How you have to solve the problems of this kind. Okay. Next, one more example I will take. I hope you got this point. You can note it down. Even if I am going to rub faster, right, you can pause the video and you can write, so that video will not be so lengthy. Next, one more graph I am going to plot. Like this time I will take velocity time graph, velocity and time. See carefully. Like this, the body has been moved. This time, this 2 seconds, this some 4 seconds, this some 8 seconds, 2, 4 and 8. See carefully. And this value of velocity 8 meter per second, let me say. What is the velocity? 8 meter per second they are given, for example. Okay, now questions will be like this from this graph. Variation of velocity with time they are given. They are asking to find out what? First question is, what is the displacement? Displacement from 0 to 8 seconds, question mark. Second is distance traveled. I think here distance and displacement both are same. Why? Because velocity is in same direction itself. All throughout the velocity is positive value. Somewhere if you are going to get velocity is negative, then it will be in the opposite direction. So no doubt in that. I'll show that example also how to solve for it. Second one, acceleration. Acceleration at 3 different points I want. Acceleration at first one, 1 second, second one at 3 seconds, and third one at 6 second mark. This is what the graph they are asking you to find, various parameters here. What parameters they are asking you? One is displacement, in between where 0 to 8 seconds. Here acceleration, at 3 different points they are asking to find the acceleration. How to solve? First problem is like, to find the displacement. If you find the area, it is enough. We are going to find the displacement, right? Area of the graph gives displacement. How to find out? Here area it will be equals to, see how to find out the area, tell me here now. Area it will be equals to, this is one triangle, this is one rectangle you can say, and this is one more triangle you can say. You can take the sum of these three, or else you can take this one as a trapezium. Trapezium you can take and you can find out the area. Area of trapezium is what? Half into sum of two parallel sides, 0, 8. This is 8 plus, this is how much from here to here? 4 minus 2. 2. Sum of two parallel sides into distance between two parallel sides. How much is the distance between two parallel sides? 8. Like this. Okay. Even if you solve half into base into height plus half into base into height of this plus area of this rectangle, whatever it is, you are going to get. Okay. If you simplify this, how much you will get? 8 plus 2, 10. 2 5s, 8 5s, 40 you will get here. This is 40 meters is the displacement here. Displacement of this body, it will be equals to what? 40 meters. Like this you have to solve for it. This is what displacement of the body when it has been moved from where to where? 0 to 8 seconds. Next, what will be its acceleration at 1 second? 1 second means here only, no? At all the points how it is moving with uniform acceleration from 0 to 2. How to find acceleration from which? Second one, first one is like at t equals to 1 second, t equals to 1 second, a equals to, no doubt, delta v by delta t we have to find. How to find out? This is delta v, 8 divided by delta t is what? 2. 8 by 2, how much? 4 meter per second square. First one. Next, at t equals to 3 seconds they are asking. 3 seconds means this one only, no? See how velocity at this, during this time, velocity is how much? Constant. In case of uniform velocity, acceleration is how much? 0. Why? There is no change in y direction. Delta v is 0 here. Here at t equals to 3 seconds, a equals to 0. Why? Delta v value is 0. Delta t value you are having. But what is value of delta v? Throughout all the points v is constant. That means v2 minus v1. Delta v is 0. So if delta v is 0, then acceleration will be 0. Next, at next one is what? At t equals to 6 seconds. At t equals to 6 seconds. 6 seconds means somewhere at this point only, no? Once again, how it is? Retardation it is. Retardation means its acceleration is decreasing but in the opposite direction. Sorry, velocity is decreasing, right? Velocity is decreasing means what? It is going to be retard. Retard means a equals to, how to find out here? Change in velocity is what, no? Sorry, initial position is this, final position is this one. Be careful while writing the sign for it. Very important. Magnitude, if they ask, nothing to bother about the sign. If they ask retardation during this t equals to 3 seconds of time, you have to include the sign. Final velocity is going to become 0, 0 minus initial velocity is what? 8 seconds. 0 minus 8 during t2 minus t1. From here to here only, no, the body has traveled, means during 4 to 8, means final time is what? 8 minus initial time is what? 4. That's why this is minus 8 divided by 8 minus 4 is what? 4, or it is minus 2 meter per second square. That's what the retardation is. That's the value of a at t equals to 3 seconds of time. One more typical problem has to be explained, but as of now the time, I think it is we are shortage of the time for that problem. Let me discuss that same problem in the next session, so that we are going to wind up with horizontal motion. and next we can start with vertical motion, means motion under gravity. In the next session I am going to start, and we need to discuss some problems on them. Numericals has to be done for these, all the problems we have done on horizontal motion, and what graphs we have studied. We have to have a brief analyzation of the graphs, even analysis of the graphs. It is very much important for competitive perspective. They are so important. Keep that point in mind. Different kind of graphs they are going to give, and they are going to ask various parameters from them. Just like in the position time graphs, how we have solved for uniform acceleration, positive whether it is or negative curve, how it is. Different types of curve they are going to give. They are going to ask whether it is so and so value is positive or negative, whether it is uniform or not. So kind of problems they are going to ask with that, which are all important perspective for competitive, right? We will see them in the coming days, right? Or in the coming sessions we are going to have the discussion on them. So with this, I am going to wind up the session. More on the graphical thing, what we have discussed today. Please have a look back of all those graphs, what we have studied. Importance of graphs in each and every part of different displacement time, velocity time, acceleration times. Which parameter can be found by what exactly, slope or area of that graph, or what does it gives. Just once again go through and make a note of all the points what we have studied for today. Okay, thank you.